I think when I compare the, yes, yes, you mean these two, well, this height variation as well, but the tendency here is more more clear compared to this one with a very high, if you look at here, and when I computed the correlation for this, it's mostly very close to zero.
The experiment in the left graph,
yes.
on the right, extreme one.
This one.
Yeah, that one. Suppose you leave those data out, what would happen?
Yeah. But these, if you look at this place, you can see, if I would fit something linearly, I would fit something like this, even without this data.
Yeah, okay. I thought it was also clear.
You mean what if I remove this data, yes. Right? I left with this data.
If that's a single experiment, then one experiment has a big effect on this relationship between these.
No, I don't think this is from one experiment. No, I don't think so.
So you stick to your statement that it's
yeah. Yeah.
Okay, then we go on. If you go to page 41, you talk about this nitrogen efficiency. It's in the first paragraph of page 41.
Yep.
And you discuss a few things at the end of that paragraph. That there's a risk that you lose milk if you underfeed with proteins. And so
yep.
farmers who don't want to take risks by overfeeding protein. But there's also a benefit of feeding protein.
But the benefit of feeding more protein is to make sure that we don't reduce.
Yeah, but there's another reason why farmers like to overfeed protein. And it's not mentioned, but farmers quite often they like to feed more protein because they have the impression that the animals consume more better. They have better intake.
But
just because of that they have more milk, maybe not so efficient.
Yeah, but
that's
when
one of the practical reasons I think
okay.
why farmers really like to solve
okay. To be honest, I think to my knowledge, I agree with you, but to feed more protein to make sure, well, because the increase of protein also increase of intake, but the reason is to make sure that they have enough, they don't reduce milk yield, and the reason is I think it's because of the milk yield, because we use dry matter intake and then to produce milk in the end. But then what I try to say here is that what happens if we try to explore a certain level of crude protein that's allowed to maximize milk yield, but not to be too much over. That's what I try to argue in this sentence.
Yes, I know, but I think if you discuss
okay.
why farmers act with protein nutrition as they do, this is also one of
okay.
the
You mean practically?
To mention.
Okay.
Yeah. Then another more general question about models that you use describing the route petitioning. It's after digestion of the model. So I really was puzzled why isn't it really an important issue to include the digestibility of the diet as well in your diet? And the reason why I ask this, if you go to table 4.1.
On which page, please?
On page 69.
Okay. Yeah.
You just check the residual prediction errors.
Yeah.
At several points in the introduction, and I think in this chat as well, I'm not sure, but I remember it's at several occasions you say that the difference between animals is not so important as variation in digestibility.
Well, I think
you calculate it backwards with an assumed DE value of the diet.
Yeah, right.
And you calculate the dry matter intake, that's what the model does, if I understood correctly. You get a huge variation in the residual prediction error.
Yeah.
So is it not like my question is it not proof that it's far more important than what you stated in your introduction?
Firstly, I agree with your argument, and this was actually one aspect I took into account at the beginning of the second study, where we see that in the we have genetic potential, we have some energy constant to determine energy provided for that. And then I think it's better to go back to that slide. Okay, yeah. So we have here this thing, actually, we have Eg, which is the dietary energy density. And in this case, we fit. Of course, I agree with that. In this case, we assume the digestive efficiency between animals are the same. But at the beginning of to start with the second study, I was aware about this fact, and I tried to argue that we need to multiply. For individual cows, there might be different variation in digestive efficiency. I agree with you. And I try to include another parameter called alpha or something to adjust for the variation. So the first step, that's the idea, but at first step we tried to do this, and we found, more or less acceptable. That's why we finally did not take into account the corrected factor to take into account the variation in digestive efficiency. But we were actually aware about the variation, in possible variation if there is.
Yes, I understand that you had to focus. You cannot do all things at the same time. And you did check organically in the start to get that part as good as possible.
Yeah.
But the question primarily, do you think it's important to address in the future? Or is it indeed not that much important as you more or less say in the start of your introduction?
To me, it is important. First, but as you say, firstly, I agree with you that when we talk about feed efficiency, there will be two parts. One part is milk, it's nutrient partitioning, which is dilution of maintenance fat. The other part is improvement in digestibility of the feed. I agree with that. And firstly, because the main focus of this thesis on the second part, but I am very interested after this to indicate, to try to include the variation in the digestive efficiency between the animals. So I think I agree that it's very important. And to link on of that is because in this case, as you can see, I define feed efficiency as simply the ratio, which means take into account mainly the nutrient partition part. But when we move to another definition of feed efficiency that I'm very interested in as well is like residual feed intake, where in that case, the variation in digestive efficiency become even more important. And the case of 50-50, you say, in that experiment, they control the...
How did they determine this 50-50?
Well,
I'm honest, I didn't check the reference, so I don't know.
Yeah. These results I obtained from the prize, but what I understood is that in that experiment, the experiment from longitudinal data, they have two breeds, and they have detail and they control the feeding, where you have the same feeding, and the same feeding but two selection line. If you observe the increase in milk, and you can actually compare what happened in the selected line and what happened in the control line, and the difference is actually 50-50. So what I understood from the experiments.
I'm not sure whether I understand, but I think for the sake of time, I have to go to another question. Do I have time for one? You mentioned, you compare, you distinguish more or less the Garon's model, as you used it, compared to the Boltier model that you referred to. And you say more or less they don't have genotype in them.
I don't mean that. I don't try to oppose that. I just try to indicate that there's two alternatives that we can use. And in this case, the Garand goes from top to down, and the other one goes from down to top, and just what I meant. I did not try to oppose that Garand is perfect.
That was also my question. My question is, do you think you can use these far more detailed models? I can imagine you don't want all the burden of all these details when you want into these kind of studies. But could you in principle use these
I think it's possible, but I'm not, to be honest, I'm not very um, good at. I mean, I, yeah, mechanistic model and yeah, but I think it's possible because in mechanistic model, you also have parameters. Those represent different genetic characteristics of the animals in digestion and converting feed and things. So I think using those parameters, it's also possible to do this kind of work, I think.
Okay, so you think it's, and you can do exactly, what distinguishes the Garon's model then in its whole approach from taking those models and fitting those genetically related parameters? If you have a selection of parameters in those models, could you do exactly the same study as with Garon's?
I hope. I'm not sure, to be honest. But to my knowledge, with the mechanics model, with some parameter that's describe the conversion efficiency, and I believe that it's also possible to do this kind of work as well.
Yes, they do of course have the parameters about capacity for mildew
And
and they are different parameters from,
yeah,
I think, the more description of the dynamic profiles that you have in this model.
mm,
Maybe that's one of the complexities. That's getting really too complex. Maybe that's the answer. I would like to give my answer on the question, but if maybe you cannot reproduce these nice curves with the parameters as they are in this complex model in old models. That might be with Garon's model you have far more easy and better description of these profiles of eating nutrition and mildews and molecular exchanges. But I'm not sure. I think nobody did it, so okay, then I have my guess. Give the word back to you.
Thank you. Lily?
Okay, thank you. Paul, I'd like to start by congratulating you on a really nicely put together thesis that was genuinely very much read.
thank you very
And
much.
really, I think probably everybody who's read the thesis would appreciate the fact that it's extremely long as well, so thank you.
Thank you very much.
So I do have some questions, and the first one is it's about residual feed intake. And you mentioned this, in fact, you made quite a big deal of it in the introduction of residual feed intake. And I was perhaps a little surprised that there wasn't a kind of link in to the research chapters with residual feed intake. I wonder if you'd like to take the opportunity to explain why that was, or your
I think
decisions there.
yeah, in this case, I agree. However, in this kind of garage model, in this current version, I think it's not possible to compute or to evaluate feed efficiency in residual feed intake terms, because what I showed you here, these kind of things are, at this moment, assumed to be common. And that's actually one of the components of residual feed intake. And it's the same for maintenance level. It's also assumed to be more or less the same different animals of different genotype cow, but this another thing, this is another component of variation in residual feed intake. So I discussed this with Olivier last time, but this maybe in the future it would be very valuable to play, to have not to not assume this to be constant, but to play with this kind of parameter to get back to residual feed intake evaluate, I think.
Okay, so that was my next question, was really around whether you think it would be possible to develop a model. So,
Yeah, in that case, I think we need to study more to see how we play with these kind of parameters, because at this moment they are constant. But that's my idea. But I don't actually know how to at this moment to play with us. But I think it's
well, that actually leads to my other question, is whether there's any information available on the efficiencies of the various different factors.
on feed efficiency between genotype of cows.
No,
On digestive.
the actual energetic pathways. So say the efficiency of converting feed and what variation that might be.
I think at this moment in literature, I think there's possible data to do that kind of things. To firstly determine the difference between injected and predicted energy, and thus allow us to see if what happens if they are the same level, but what source of variation of that difference in the intake. So that can have to study variation in the digestive efficiency, I think. at this moment, I think it's available later in Jericho.
So I guess to go back to my original question,
Yep.
I was still somewhat surprised that you had people feeling intake as a major topic and why you didn't make the decision to put it on the thesis. Could you repeat what I said?
I think at this moment, wow, with this kind of model and with the, firstly, in the introduction, I agree that I introduced the definition of residual feed intake, and also it's important in this context. But I think this, in the end, we decided to work with gross feed efficiency, is to partly because also the current characters, the current capability of the model to capture that. That's also the reason. And the second thing is the part which we hypothesized that the nutrient partitioning play on the feed efficiency and also on the long-term consequence, which is on fertility and health and of the animals, I think.
So let's put aside what's in the thesis and your own perspective on whether we're better off selecting for residual feed intake or growth efficiency or nitrogen efficiency, or what sort of combination of things do you think we should be going for?
To me, I think at this moment we have two arguments. The first thing is if we want to have a cow that produce a lot of milk, that is important because we want more output, more milk, more money. I mean, and also at a certain point, especially when we increase, when we have more people, that means we also want the high yielding group, but they also have a better capability. So, for example, I have 100 animals in high yielding group, but maybe some of that 100 can have some animals that inherently have more capability of digesting food or chemically converted energy to milk. So I think it's the combination between these two definitions would be very beneficial, because the residual feed intake to me it's independent from the production level, right? And then the more efficient animals can be a very low yielding cows. So to me, it's the combination between these two. So firstly, the ratio one, and the second one is to, at a certain point, we put in the residual feed intake to select out those animals that's more efficient inherently. But of course, in that context, we need to again think about those, for example, new group with a very high efficiency in terms of residual feed intake. But then we also have to look at the health and fertility as well. Because what I read in the literature now, they're increasing paper to report the correlation between residual feed intake and the fertility aspect. But not a clear conclusion, I think, at the moment, what I read.
Okay. So should we also be including nitrogen efficiency, or do you think the correlation is stronger?
In the concept of, as I said, is on the general diet. But I think more on a general diet, I would say yes, to include nitrogen efficiency. What I saw in my study is that on a general diet, we found a strong correlation. And I think if we keep selecting animals and using the same diet, I don't think it's maybe not important to take nitrogen efficiency. However, I'm not very sure in different case when we move to different diet, would have different quality. I mean, then in that case, probably nitrogen efficiency needs to be taken into account as well.
So I have a similar question to Andre in terms of the scaling factors. And I've written it in these fairly blunt terms. The
Well, but by doing this process, I don't mean that. Firstly, I don't think about cheating process, but that's the process of deriving the estimate. So what we use in the model is just a numerical values. But what actually happened is like, for example, now I have 31, at peak milk yield 31 lactation curve. How can I represent that curve in the model? So to me, that is the process of deriving or of obtaining the numerical in the model that can represent what happens in the reality. So for example, in this case, I present to you, not here, but in this case, we have the default value. For 1 is equal to peak milk yield of, I think it's 24 or something. And that means when we increase this number, we can easily represent what happens in the reality. So that's the way the model works. So, and in the previous version of the Garant, they try to try some combination between, for example, new x, new y, and new f, for example, to represent the cows. But this was just very theoretical in the last version. We don't actually know, I mean, in the last version, they did not actually know which, in this combination, it actually happened. Because it's impossible to say, I have a cow with 200 kilo, and that cow produce 50 kilo milk yield per day. But that's why in my second study, we provide this kind of situation for Danish red, if the mean of that should be around a certain range, and the same for other parameters. So this kind of information, we think it's an accessory. If we actually want to, now, if I want to simulate a population of Danish red, with this information, I think it's more useful to think about that. The mean of that, it should be around this place. The mean, for example, mu y of Danish red should be like something this place, and not be like 3, 4, for example.
So this is actually good that you have a table up exactly on the last week next question, which is around, you have the mean and standard deviation of the population, but for each individual, do you have an idea of what the standard error might be?
Of
So when you estimate, say, the X or the Y.
that's the population level.
Yeah. You also have a standard error.
I can't calculate it, but I did not put in here. So, but I could actually.
Is it big or small, I suppose,
The standard error.
standard error?
I think no. It's for example, new y. It's vary from, I think it's between 0.7 to something 0.8, 0.7 to 8. I think in the full in the thesis, I think I presented the mean and the max as well. I think where you can see the range of in the different really high yielding cows and really low yielding cows. In the
That's okay, I think that's a good standard error.
I didn't have any idea. I mean,
That's fine. So, other than using the scaling approaches, is there another way that you could model genetics?
to my knowledge, I think there are models to use estimated breeding value to represent this. What most of the study I have is the thesis from Brian, where you also co-author on that, and that's just there's also another alternative way of doing this. I think that's also possible because he had also shown a very potential or good result in fitting quite similar works with my PhD. I think he also tried to derive to study the correlation between those parameters to represent milk yield, to represent milk fat and body weight, I think, and also, but using the estimated breeding value and not the genetic killing parameter in my PhD thesis. But I thought that's very interesting, but with the same idea, I think.
So broadly speaking, what do you think the pros and cons are of each approach? Broadly speaking, what do you think are the main pros and cons of using estimated breeding values versus rescaling parameters?
What kind of
The benefits versus the problems, I suppose. Just in very broad terms.
I think in estimated breeding value, then we have to, if you want to have that kind of information, then we need to have to conduct a long-term and very large experiment to obtain those information for the estimated breeding values. And this kind of thing is just a new way to represent the same genetic potential. So that's, and also it's, I think it's easier probably compared to estimated breeding value.
So, I've got a question on your thesis, which is thinking about today. On page 75, which is figure 4.5,
Okay.
you've got a PC analysis. Has Holstein, Yorkies, and Jerseys. And Jerseys seem to be slightly different.
Yep.
Why is that?
Fine.
Why is that? What's your explanation?
I think this is represented by the fact that, well, they identified that this PSA analysis actually really clearly identified the difference between breed, where they have Jersey is much smaller in reality compared to the other breed, and also they have a higher concentration of milk fat, milk protein, and milk lactose. And this also represents the fact that the model can adequately capture what happens in the reality. So if I plot this information, I mean in terms of the biological traits, I would expect them to have the same here. So that would mean the model can capture what happened in Jersey, and can capture what happens in Dennis Red and Dennis Holstein.
I know you're not a geneticist, but you talk about genotype and environment interaction. I just thought I'd explore with you, if we have time, what your interpretation of that is.
To me, the genotype by environment interaction terms. Firstly, what is mean in this case, for example, I gave an example where, to me, I understand the two ways. It's good, and it is what I found. It does. Firstly, the animals they are normally selected in optimal condition, but now if they are moving in different environments, and where I do the same change in the environment, this kind of animal have a different effect. So it's making things more difficult to be predicted. And that is in terms of the re-ranking. And the other one is also about scaling. That means, for example, I think one easy way, an example is the Holstein Friesian is normally low efficient in the very poor diet. But when you move more and more to very rich diet, they perform better and better. So that response on the same chain, bigger and bigger, compared to maybe some low yielding cows. They may be very good in the diet, but when you move, the response may be less than the Holstein cows. So we have
That's a very good answer. Just a couple of questions on chapter 5. And one is general question. I've noticed that you put up some of the results. Is the thesis going to remain the same, and the chapter finished for inputs and conclude to be quite different from the chapter, or how do you see it?
to me, firstly, it needs to be updated in terms of the results. For example, even the table, so I have here the results of Lepant data, where you can see very adequately predicted Hodson and under-predicted nobody. And also, when we compare to Langhill cows, this result could be in the new paper. And I also have the result for the feeding and the effect of high versus low feeding. Probably I can show you if you want. High versus low feeding, that's probably you like to say. In the last version, we simulate, the model simulated very negative effect of low feeding compared to high feeding. That's what you found in the last version. But now with the change in the, but in the last version, we had only two parameters to represent the counts that are variation, that are varying. But now I already include the other two more parameters called V0 and new X to represent the capability of animals into mobilizing and in storage. That means in that case, we have more possibility to fit the body condition score curve. In the last version, there's only possibility to fit milk yield and the body weights, but actually the same body weights are more or less the same, but when we change body weights, there's some change in body condition score, but then it was not captured in the last version. So in this version, I include those two parameters. So I found these results very close to what you in your paper to report about Langhill data. So I think that's one of the very promising results of this model compared to the last version.
I think that's very interesting to see the survival lifespan effect with your data. And it shows obviously a very positive correlation between.
In terms of the lifetime efficiency, of course, I'm sure that no one reports this kind of thing to be compared. But in terms of the lifespan, what I compare from one of the quite recent study of Ellen Wang, and she reported quite close to this kind of number. It's about 2,000 or something. But in this case, we need to be aware that in this case, we did not consider the effect of, for example, the metabolic disorder on the health. That means this is also one of the determinants of the lifespan. So, I mean, at this moment, we would only expect that it's quite close to what we have, but I'm sure that it's not. Yeah. But by including that, I think it's would be improve the quality.
So Alan, just one final question then is, do you think that having the health data will dramatically alter the conclusions?
I believe this.
So I want first to congratulate you for the very clear presentation.
say yes. That's right.
Sounds it. But in other terms, do you think that with your study you can incorporate this notion somewhere?
I think that's one of the limitations of this study. We could not include, for example, the effects of other parameter on this analysis. So we mainly focus on, in the end, we mainly focus on what we call dilution of maintenance. I think it's mainly affected by the level of milk yield and not the rest part of digestive efficiency. Like I said, we assume in this case could be predicted using some equation from the other meta-analysis in our case.
Do you think that it should be much more important for the within spiral radiation or between spiral radiation?
Within, I think, yeah.
Why?
Well, in this case, we see that our data we obtain from different study where we have different noise. And it's again, it's a legitimation of this is that when we took within limitation, we can look more clearly in what kind of factor actually contributed to this kind of correlation. By grouping the data, or I think we were onto trying to do the principal component analysis in this case to see if high efficiency animals are actually distributed in which kind of feeding diet. But that was the idea, but in the end of the time I couldn't have time to do all of the things, and we decided to just stop at a certain moment to move to the second and first study.
I was a little bit surprised that the nitrogen efficiency is not affected by the content or level of TCP intake. How do you explain that? There's quite a lot of articles that tend to show that there is a very sensitive response of nitrogen efficiency to the nitrogen intake. So
I think that's why we did not include the DCP in the model for predicting. I need to check. No, in this case, milk yield and
in your tables,
yes, I found
no
this
significant correlation.
the nitrogen efficiency.
It's totally possible that there is no impact, a significant impact of this variable in the model. My question is why? Because a lot of other results tend to show big and significant impacts of the nitrogen intake on the nitrogen efficiency. And probably one of them will reduce the to increase the nitrogen efficiency.
Right, right. Yes.
Sorry for the question.
Yeah, I agree with you, but at this moment I couldn't find the right argument for that.
Okay, if you don't
Yeah.
have an answer, I can speak because I have a question.
data, but we had that in the database. For example, where the study come from, and what kind of you mean in here? Okay, but in the thesis, the description of the variation in the protein and in energy density in NGF. I mean, that's the composition. And in our database, we also have that kind of information: experimental design, number of animals, state of lactation, and what kind of additives they use in that. I mean, and different other options as well. So those information are actually included in the database.
Yes, but my question behind was, do you think that if you select, for example, treatments in which just the nitrogen content arise and not the energy, and you detect a response, you will still observe any differences in your efficiencies of nitrogen and energy, or if there is still a correlation between the ratio?
For me, what I just saw there, and what I believe that when we group animals, treatments, at the way you said, this correlation might change. Only in case if we select, I think on the range of that I saw you, I would say that the correlation remain the same. But when we move to group treatment in protein and energy, the correlation might disappear, I believe. For example, you do one level concentrate, and this just by this way. And I don't think that we can observe the positive correlation like we observe here.
The last question on this part, you use both INRA and NRC equations. I guess that when you look at NRC and INRA shouldn't be so different. So why do you use two types of systems? Is to be sure that we got each other in journal themselves?
Well, the NRC system doesn't. We did not use for the feed-in values. We only use for converting energy to, the equation to convert. For example, the fat corrected milks, and but not the feed-in values. The feed-in values we use from INRA.
You have an hypothesis in the experiment, the Spanish experiment, that the feeding management is not a limitation for the genetic potential.
The step-down reduction feeding.
It's a statement. How can you justify this statement with a constant diet?
Pardon? Can you repeat your?
How can you justify that your feeding management is not a limitation to the expression of the genetic potential in the cow?
I think that's a very difficult question to do. In reality, I don't think we can. We just try to keep the animals in the situation that it has within good quality of feed, and the environment in terms of temperature, and also the energy should be constant. But in this case, for example, firstly, I think it's difficult. And in our case, for example, even we keep the constant energy density diet, but because of the experiment go through this year to next year and so on, and that's in that case, even we say it's constant energy density diet, but actually it's probably not always, because in this year, the quality of feed might be different from the next year, and for example. So to me, I think it's very difficult to justify that, but try to
next question will refer to your lifetime efficiency. For you, it's just a function of milk production. So do you think that milk is a
So what do you, well, that's what my argument does at this moment, to be simple, and I only consider milk yolk as a function of feed efficiency as a function of milk yolk. But I appreciate the importance of taking into account other important aspects. In that case, like the number of bowls to be produced for making yogurts. I think at the farm level, that become important as well, not only milk.
Yeah. Because when you compare some breeds, for example, you have Jersey cows and you have normal cows. If you are going to a slaughter house, I guess it's different. And if you have calves, I guess, especially for the males,
I agree.
it's also very different. So do you think that you have to integrate this kind of meat production in your index of efficiency? And if the answer is yes,
To me, answer is yes.
of course, thank you. But the other question is how? How did you intend to do that in order to have a better index of this lifetime efficiency? Because you have two products to manage. You can find others in
Yeah.
other countries, but here we have two.
But we also have the information on body weight in this case.
Yes.
That's the model can simulate on that. So I think it's the way that we see how large the animals in that case if she's gone to the slaughterhouse.
Okay. How do you balance these two variables, your efficiency?
The body weight and the milk yolk.
Yes, but you have two variables, so the ratio should be considered differently. Otherwise, you have two ratios. Because you have all the energy intake during the lifetime.
In that context, I think it's not the ratio, but it's the kind of selection index, the additive things, how much you put for the milk yolk and how much you put for body weight, if you like to. You select animals with, I mean, it depends on the farmer. If you like milk yolk, you can put more weight on the milk yolk. And you add another selection index, which in terms of body weight. And if you like to have a higher milk, high body weight, you can put more.
The question is not what I like. The question is concerning your introduction about the sustainability and the global food system. If I want to reduce the environment impact and maximize the energy and food production for the humans that involve both milk and meat, what could be important to consider in my index in order to be sure that I want really to reduce the emissions with the maximum products to feed the global food system?
In that case, I would say that we also need to select for the animal with the smaller size that produce the same level of milk. They're going to have a less amount of energy for maintenance.
Okay, I think that in your conclusion you address the notion of rural herd models and so on, but again the question of the two products or two main products that are really core products should be considered in the notion of efficiency, because there is a big trade-off between generally the milk production and the meat production. So when we upscale the analysis, generally the conclusion could be misplaced by the notion supported just by one indicator.
Okay.
It's particularly true when you mention that it will decrease the methane emission, because there is a big debate about the allocations methods to attribute to milk and meat, and according to the method, you arrive to a very precise conclusion about the importance of the genetic selection in the production. And a lasting question perhaps concern the calibration of the production model. You see very rapidly how you estimate one parameter, but it might be just one, and you only need type of information because the the curve
Okay.
is not easy to parameterize. And
Well, firstly, those parameters, we those parameters are obtained from those studies that are tried, because we normally know that these kind of body conditions called energy balance and milk yolk are co-correlated. So I chose two experiments from Wright and co-worker in 1992 and Kochenik in 2011 that try to separate this kind of thing. For example, here, an example from Wright and co-worker in 1992. If you look at this, you can have a two group of cows with the same mobilization rate, right? On this, in here, on this random data is mobilization rate. The change in body conditions called indicate mobilization rate. And if you look at here, it's the same mobilization rate, but because they have a different fatness. So in this case, the moving from fat to thing increase the day, reduce fertility. So by that way, we determine the initial value for the parameter for the coefficient to do in the curve of energy balance. No, in the body condition score. And by doing this, they have the same body fatness, but they have different mobilization rates. So by doing that way, we obtain the parameter for energy balance.
Can you choose a multiplying model?
Yeah.
Multiplying the three effect?
No, each parameter is so in
yes,
here.
Yes, you are. Just for I understood how you estimate one parameter for one effect.
Independently.
Independently.
Yeah, independently.
How do you justify to use a multiplication of the three effects to address the good response?
I don't understand
the
that.
additive model of the three impacts could be another opportunity. How do you justify the fact that you have the three coefficients multiplied? It's just to
put them together.
Yes, but are you sure that it is multiplying?
This is our assumption, I think. It's not. You mean, for example, if this effect is actually additive or multiplication, something like that?
Yeah.
I think at this moment, we assume this to follow that kind of thing.
Okay, so I think my last will be just a comment. I totally agree with you to support the long-term trials and this to be used. My only question is how do you intend to fund the same in the future?
Finance.
One of the most question scientists in this area.
Okay.
Thank you very much.
Thank you very much.
Thank you, Philippe.
As I know that you have done tremendous progress in French, as we are France, I suggest you to speak French and feel free to understand French or English. Okay?
You speak French.
Yes.
To be honest, for the
Slowly. Not worrying.
for the academic, I will try my best, but I'm not sure if I understand completely the academic language in French. But
no problem.
okay, we can try one or two. If I don't understand, I will stop you. To be honest.
Donc j'ai été très intéressé par la lecture du travail
Ouais.
et j'ai appris beaucoup de choses parce que je n'ai pas l'habitude de travailler dans le secteur génétique du aussi. Donc je te félicite pour tout ce que tu as fait. C'est un travail impressionnant.
Merci beaucoup.
Je te félicite aussi pour ta présentation orale, qui est très claire. Par rapport à l'utilisation du modèle
réponds en français ou en anglais?
You can answer in English.
Okay, I think the first question related to the underfitting of milk yolk in the end of lactation. And I just explained before, what we thought in this case is mainly because this is the curve that Gavin assumed, and this curve is fixed in the Gavin. I mean the shape. In terms of the shape, it fits, and we assume that fit, and we did not touch those parameters that were calibrated and that were assumed by the author for developing Gavins. But in this case, what I found in the data that Olivier used for developing this, for calibrating this shape, is from those experiments, is actually in the religious hut from Minnesota, I think. And in this case, they normally fed with the step-down reduction feeding, where in the end of lactation especially, they normally reduce the energy density of the diet. And also in this case, the environment is normally not controlled as very well as the data that we use, which is constant feeding. So what I believe is that in the end of lactation, this curve, if this is reduced like this, and what we found in our data, the curve should be, in the end, should be maintained. So it's like kind of more persistency compared to the data. But so that's because of this. It's explained for the observation of the difference in the shape. But of course, in this case, like go back to Garant, because the Garants have two systematic parts. One part is regulating the scaling. The other part is regulating the shape. So if this problem really big, then we can actually come back to further working on the systematic, the shape part, the regulating submodel to allow this curve to be changed. But at this moment, I think it's acceptable. It's at acceptable level. So.
La deuxième question concerne l'analyse en composante principale. Page 74, si tu peux montrer la figure. Tu l'as dans tes slides.
Oui.
C'est la sortie des composantes 1, 2. Oui. J'ai été surpris que les critères de production, tu as 4 critères de production de lait.
Oui.
De lait brut, enfin le liquide, en bas.
Oui.
Et ensuite, les productions de lactose, de protéines et de matières grasses.
Oui.
Et j'ai été surpris de voir que ces 4 critères ne sont pas mieux corrélés sur ce plan. La première surprise. La seconde surprise, c'est la place du critère de mobilisation qui est en fait très peu expliqué par ce plan. Est-ce que tu peux me dire quelques réponses par rapport à cette question?
You mean there's no correlation between UY and the other three? Well, what we found in here, there's a negative correlation. For example, if